Okay, good evening all. Right, so let's now we have finished management, internet security. We need to do few more past paper questions. Professional practice, we are pretty much done. UCSC has not published this one anyway. This and this. So here in system and network administration, sorry, we are in the middle of the third topic. Most of the questions are coming from third and fourth topic. Okay. Uh, so I'm not going to continue the third topic today. So what I thought is doing the sixth topic because these are small topics so that you have better chance for you to prepare because this will take more time and these are more fussy topics. So therefore, let's finish these two topics. So then topic wise, we are pretty much done. So then we can do these two last. Okay. These are the more practical fussy topics. Okay. Right. Virtualization. For this, I have uploaded a new note today. Right. We can finish it because it's a very small topic with past paper questions also. Remember, when we do a topic, we do it past papers also, right? So therefore, gradually, the topic is fully finished. Okay. So for this one, virtualization, I have uploaded a separate note also under system and network administration. This is the last topic, virtualization and cloud computing. And plus, you refer your UCSC note. Okay. So now I hope you guys have the access to the Google University VLE. So you can get the university note as well. Okay. Uh, right. Let me open the note. Right. Virtualization and so this note pretty much cover almost everything in your UCSC note plus additional things. I have removed few things from the university note because I felt like those are little bit not for import for the exam. Okay. But I have added a lot of new things also. Right. So this is not a technical topic. So that is why I want to finish it. Okay. 100% theory topic, no practical aspects, no hands-on things. Right. Virtualization and cloud computing. Sometimes you get one question or you don't get a full question for this one. Just one or two sub questions, sometimes three sub questions. Okay. I think 1 year there was a full question. If you get a question from this, that is easier for you guys, right? So that is a good sign that your exam that year is easy. Right? Virtualization and cloud computing. So what is virtualization? So these are related. That is why they have put it together. Virtualization, cloud computing benefit from virtualization. Okay. So you can use virtualization without cloud computing. But most of the time, cloud computing use virtualization. Okay. Right. So what is virtualization? Of course, it is not new thing for you guys because we all already use virtualization. When we do Linux Ubuntu, remember I run Ubuntu in my virtual machine, in my Windows laptop. Okay. So that is virtualization. So virtualization means you create multiple simulated environments in a single hardware, right? Single hardware, you have multiple machines. So virtual machines, virtual containers, right? It's a broad word. So then what is cloud computing? Cloud computing means you provide computing resources like servers, storage, database, file storage, software, right? You deliver it through internet. So you connect to us and use it rather than we give it to you. Early days, we give the software for you to install and use it. These days, software is with us. Using web interface, you access the software. Okay. So there are pros and cons. Not only software, servers, storage. So early days, we used to keep our data in our machines, our servers. These days, we keep our data in uh, cloud. For example, all your documents are in Google Drive, cloud computing. All the recordings I uploaded to YouTube, cloud computing, cloud storage. The Google Classroom is not hosted in our web server, cloud computing. So this Zoom session, I can save the recording to the cloud computing. Okay. So these Facebook and other things, most of the contents coming from clouds. Okay. So cloud computing is super, super important. So key driving force behind cloud computing is virtual servers. So you need to understand the connection also. Okay. Right. First half we will look at the virtualization. Second half we will look at the cloud computing. Remember you have the essay paper, right? You need to explain your answers. So therefore be very serious because you don't have MCQs. When they ask a question, try to give very precise answer and also then explain it because this is essay, not structured essay. Okay. Right. So what is virtualization? It's a process of abstracting physical hardware resources like CPU, memory, storage, network into multiple isolated environments. Right? It can be machine, it can be a sort of a container. In general, yes, we call them virtual machines. So that means your main memory RAM is abstracted out into different virtual machines. So this is say 100 GB. Maybe each machine will see 33 GB RAM. But this is virtually. But actually this is part of this actual RAM. That is called abstracting physical hardware resources. And each virtual environment, if it is mostly these virtual machines, has its own operating system. While there can be a big operating system hosting all these virtual machines, or we call them hypervisors. So there are a lot of advantages, disadvantages when it comes to virtualization. So these are some features when we use virtualization for you hosting your servers and of course cloud computing. You can do live migration. That means you go from one virtual machine to the other virtual machine live without say you have hosted your web server in a particular cloud. So you want to take it to a different cloud due to some reasons. So you don't need to shut down your servers. Live migrations are possible. Okay. Not all the time, but most of the time. You can create a image of a virtual machine and give it to someone so that they can quick and fast set up the environment. Okay. With all the servers set up, environment variables configured. Especially this is very famous in software development fields. So you can quickly create production environment in a virtual machine. So just take a copy of that and put it there. Okay. Virtual machine images. And of course, containerization. These are the important words, right? So in your questions, they check whether you know these things. So that is basically you isolate your environment. due to security and other reasons. Okay. Containerization. So you can run different applications in different containers like JVM, Java Virtual Machine, .NET environment. So it's not always running a new virtual machine. Sometimes it's a container, little bit lower level than or high level than or virtual machine. But when we say virtual machine, it's basically you have a separate OS as well. So these are some basic terminologies and components when it comes to virtualization architectures. The host machine. So this is your big OS. Sometimes this can be hypervisor that manage the overall hardware, host OS. So then hypervisor software that facilitate virtualization. For example, in my laptop, my host OS is Windows. Then I have Oracle VirtualBox software. That is my hypervisor software. Then on top of that, I can have different virtual machines with different OSs or same OS. Uh, I have Linux, Ubuntu virtual machine. So my host OS is Windows. My hypervisor is Oracle VirtualBox. I have a virtual machine with my guest OS Ubuntu. Okay. So then my Ubuntu guest OS can see virtual hardware. Part of my real hardware is shared for the virtual machine. Maybe I have say 8 GB RAM, maybe 3 GB, 2 GB shared for the virtual machine. If I have 16 GB RAM, maybe 8 GB shared for my virtual machine. And maybe few gigabytes of my hard disk SSD shared for the it's virtual hardware, virtual hard disk, virtual memory. This virtual memory is different, right? This is the actual memory we are giving, right? Host machines, hypervisor, guest OS, virtual hardware, host OS. Okay. So hypervisor is the software that facilitate creating virtual machines and virtual containers. So your hypervisor is not just software. Sometimes it's 100% software. For example, in my case, Oracle Virtual Box is 100% software-based hypervisor. But there can be some advanced hypervisors, which is a combination of software, firmware, hardware. Okay. So that is where we have the categorization called type 1 hypervisors, type 2 hypervisors. Especially these type 1 hypervisors are combination of these, whereas type 2 hypervisors are pretty much software-based hypervisors. So in my machine, I am running a type 2 hypervisor. Okay. Type 1 hypervisor, type 2 hypervisor. So sometimes the type 1 hypervisor is called bare metal hypervisors. These are the advanced hypervisors, mostly used in cloud environments. So they are on top of the hardware. First, we install the type 1 hypervisor software. And on top of that, you install different virtual machines. That means different OSs or containers and so on. So here you can see there's nothing called host OS. It's only guest OSs because hypervisor is sort of a overall OS. But this is not given by OS vendor. This is given by hypervisor vendor. Of course, these days OS vendors also now gradually providing hypervisors. Okay. So your hypervisor directly manage the hardware. So this is more efficient, right? So this is more secure. Okay. But at the same time, this is more complicated approach. But this is the one that mostly used in commercial environments like Amazon, okay, Google, Microsoft. So they mostly for their commercial cloud computing, mostly they use bare metal hypervisors. Sometimes these type 1 hypervisors need special hardware configuration, firmware, and so on. Okay. So the advantages of type 1 for bare metal hypervisors, it's very high performing and much better security, isolation, and this is ideal for data centers, cloud platforms, high big scale, right? And also better scalability, stability. At the same time, there are some disadvantages. It's more complex to set up. You need sometimes special supported hardware, firmware, right? So you need some dedicated hardware, specialized hardware. And this is not flexible option for our day-to-day desktop virtualization. So this is for professional, commercial, right? Cloud computing. So these are some examples of bare metal hypervisors or the type 1 hypervisors. So these are more enterprise level hypervisors. VMware ESXi, Microsoft Hyper-V, KVM Linux-based hypervisor, Xen Citrix hypervisor, Oracle VM Server, right? Oracle VirtualBox normal one is not bare metal. It's type 2. But VM Server, that is bare metal or type 1. So the type 2 hypervisors are the simpler guys. Uh, for example, in my machine, I use type 2 hypervisor. So this is installed on top of the host OS. This is your hardware. On top of hardware, you have your main OS. And on top of your OS, you install the type 2 hypervisor, like Oracle VirtualBox. It's pretty much OS, right? Sorry, software. You don't need special hardware and no. So then under the control of the type 2 hypervisor, you can create virtual machines, virtual containers having its own noises and so on. So that is type 2 or hosted hypervisor. So it's installed on top of host OS. Previously, there's nothing called host OS, only guest OS. Now we have host OS and guest OSs. Right, so the advantages are mainly easy to set up, simple, less expensive, right? Easy to install. Right? So this is more for individual usages like developer machines, testing environments, because we can set up it easily. You don't need special hardware. Okay. And these are mostly, we have even the free versions of the hypervisors. The other hypervisors are pretty much commercial hypervisors. You need to pay and get it. So the disadvantage, obviously, not as high performing as the bare metal. Security issues are there because it's on those virtual machines run on top of other OS, and this is not ideal for large scale production environments. Okay, more for testing, experimenting, learning, so that kind of for personal things. And so that those are the two type of hypervisors, type 1 versus type 2. So these are some examples like Oracle VirtualBox, VMware workstations. You can see the word like workstation, desktop. Okay. So genome boxes. So those are type 2 hosted hypervisors. So this is sort of a when to use. Right? For example, enterprise data center, go for type 1, bare metal. Public cloud, go for type 1. Just you want to software test in lab. You want to test your software in different environments. So maybe type 2 is good enough because you can easily set up. You don't need high performance, right? Just testing. Classroom training, definitely type 2. How high performance workloads, go for type 1. Personal usages, learning, go for type 2. Right, so this that is the main classification. Type 1 hypervisor versus type 2 hypervisor. So now we move on to another classification by implementation. This is a different classification. So there we can see four types of hypervisors. This is different independent classification. Okay, full virtualization, para-virtualization, hardware-assisted virtualization, and para-virtualized drivers. So we take one by one with some advantages, disadvantages as well. Right, full virtualization. So this is the highest level. So you have the hardware. On top of the hardware, you have the full virtualization layer. And on top of that, you have the guest OSs. So this is, you can see, this is pretty much the bare metal type 1. Okay. Now, here the guest operating systems. Remember, we have the guest operating systems. So you don't need special guest OSs. So that is the advantage. That is the main point for full virtualization. So if you have full virtualization for your virtual machines, you can just use normal OSs. You don't need specialized OSs. So that is why we say full virtualization, right? So the guest OSs don't feel like you are running in a virtual environment. It's like you are running in a normal hardware. That is why we say full virtualization. Okay. So you don't need modified guest OSs, customized OSs for the guest. Okay. So that is full virtualization. So this is a little bit of a more detailed view. Okay, hardware, on top of the hardware, we have the virtualization software, bare metal type 1. So then the normal OSs, right? For example, in there are situations you can run virtual machines. Then you need a specialized OS, but here you don't need. So that is full virtualization. So you can use for guest OSs, you can use the normal OSs, not modified versions, customized version. And this gives fairly good security and compatibility. Right? At the same time, there can be some performance issues, and the designing the hypervisor itself is complex because you try to you implement the full hypervisor, full virtualization. So therefore, these are a little bit complex software. Second one is para virtualization. So the difference is again on top of the hardware you install the virtualization software, but now on top of the virtualization software, if it is para virtualization, you can't install normal OSs, general OS. You need the customized or modified OS, customized for virtualization. So that is why we say para virtualization. This is not full virtualization. Full virtualization means your guest has no idea, no feeling about whether it's normal environment or virtualization, same OS. But now you need specialized modified guest OSs. Okay, because your virtualization layer is not sort of a perfect now. It provides some features but lacks some features. So that is why you need customized OSs. Okay, so that is called para virtualization. So this is a more detailed view, right? So this is para virtualized hypervisor. So then you need modified guest OSs. Earlier normal OSs. Okay, right. Para virtualization. Full virtualization versus para virtualization. Okay. So this one gives a little bit better performance because it has less overhead, right? Less overhead for the hypervisor. But at the same time, the need of modified OS is a big disadvantage because you can't just download OS and install it. You need the specialized OS version for that particular virtualization environment, which may sometimes it may not be available. Sometimes those are commercial. You need to pay higher license fees. Okay. So you need the modified OSs and some OSs may not support modified version. So then you are in trouble. So the third one is under this categorization, hardware assisted virtualization. So the word itself says, right? The name itself says, for this you need special hardware, right? Hardware and firmware that support the hypervisor. And again, if you have it, once you install the hypervisor, you can run unmodified OSs like full virtualization. But this is not full virtualization because you need specialized hardware. Now remember in para virtualization, you use normal hardware, but you need modified OSs. Here, you have the modified specialized hardware, but you can now use normal OSs. You can see there's a nice connection. But the first one is where you don't need specialized hardware, you don't need specialized OSs, your hypervisor does everything. So that is why full virtualization. But the hypervisor must be taking a lot of work. But now the hypervisor is doing little bit less work and expect either hardware or OS to compatible. If it is the OS that try to make it compatible, it is para virtualization. It is the hardware that help you, the hypervisor, it is hardware assisted virtualization. Okay. Hardware assisted. So here also it's very good performance and good strong isolation, right? Because you don't need modified OSs and so on. But obviously the disadvantage is obvious, right? You need specialized hardware. Okay, specialized hardware. Oh, that hardware must support it. Right. So the final category is under this classification, para virtualized drivers. Right? Para virtualized drivers. So now you need additional drivers to run your virtual machine. Okay. So hardware hypervisor, then guest OS plus para virtualized drivers. So that means to run, you need special drivers. Okay. So this approach is mostly used in combination with hardware assisted virtualization or full virtualization rather than use this as a separate approach. That means hardware assisted means modified hardware. So then you need specialized drivers. Or you use it full virtualization where you don't need special hardware, but you need special drivers. Okay. You can see that full virtualization is where you don't need special hardware, you don't need special modified OS, you don't need special drivers, still it works. Okay, that is full virtualization. But then your hypervisor is doing a lot of things. Sometimes performance issues, sometimes security issues. Okay. Right. So our next subtopic is virtualization with Linux. Of course, most of the virtualization software support some virtualization software is platform independent, like Oracle VMbox. You can run it on top of Windows, on top of Linux, and so on. But there are some virtualization software specifically targeting a particular OS. So for Linux, we have something called kernel-based virtual machine, KVM, which is a full virtualization platform. I forget to highlight that. Okay. This topic is very small, so therefore pay attention to details and make sure you go through the UC reference book, the relevant pages. Okay, if you want to get a A plus. Right. So this is a full virtualization software for Linux. So it's basically the Linux kernel itself serves as the hypervisor built into Linux, sort of a native hypervisor. So remember, when it comes to cloud computing, we very rarely use Windows and Mac machines. It's almost 99.999 times Linux machines because Linux machines are high performing, high security. So Windows machines we use for test environment, testing software and so on, right? Familiarize with environments. And these are the serious commercial servers. Right. So now we move on to another subtopic. Okay. So now that classification is over. Right. So what was that second? First one is type 1 versus type 2. That is bare metal host. So this one is the second classification where we have the full virtualization, para-virtualization, hardware-assisted virtualization, and para-virtualized drivers. So this is mostly used together with either this or this. Okay, rather than you use it as alone. Right. So now we are into a separate subtopic. Of course, virtualization in Linux is a different subtopic, right? So this is different subtopic. And this is another different subtopic that is container-based virtualization. So rather than machine, you can create virtual containers, right? Virtual containers. So then we call it container-based virtualization. So again, you have the physical hardware, host OS, but on top of the host OS, rather than virtual machine, we have virtual container or container engine or runtime. So very good example is Docker. Right? You will learn more about Docker, how to work with Docker uh, in semester 6, QA part, okay, quality assurance, and also emerging technologies. Okay. So on top of this container engine, you can have your own containers. So these are something like application environments rather than OS. Right. So rather than OS, what you need is maybe Docker environment for you to deploy your web services. So rather than a virtual machine, what you need is application environment or container. So then inside the container, you can write your application code deploy your application code dependencies and so on. Okay. So these containers are for specific tasks. So therefore it can be cheaper and also it can be optimized because it does your work and nothing else. Okay. So this is the high level Docker architecture where you can install different application containers and deploy your applications and so on. So this is a bit of a comparison between virtual machine and container. So virtual machine is a bigger guy, container is smaller guy. So virtual machine means your virtual machine has its own OS, right? Guest OS. But container like Docker container, not every container has its own OS. So it share the host OS. Because what we need is a container, not a virtual machine. Virtual machine is costly. Getting a container is less costly. So therefore, this is lightweight, easy to start, restart also. Of course, these are heavy because these are virtual machine, right? Slow to reboot and so on. So here you use hypervisor. Here you can just use container engine. So this is for full isolation. So this is for microservices and so on. Okay. And this is getting very popular these days. Okay? Because what we need is a container, not virtual machine. But there are situations, yes, we need a full virtual machine because here you get a lot of control. But at the same time, you need to configure and so on, right? But container is sort of a ready-made environment for you to deploy your services and so on. Remember, we are in a very dynamic, fast-moving society. In fast-moving society, we don't have time to spend time configuring servers because by the time you configure your servers and so on, the technology has changed. What we need is quick deployments, quick setup so that we run our business, keep updating our businesses. So these are from your UCSC notes. Some Docker frequently used commands. Just remember these commands. Most of these commands are Linux commands like rm, top. Okay. So they can ask because otherwise they have nothing much to areas for ask questions. So just and also go to the UCSC note. Okay. It's just must go through the UCSC note, go through the relevant pages specified in your syllabus. Just few pages, maybe just 10, 20 pages. Right. So now we move on to the second part, cloud computing. So we'll take a small break and then move on to cloud computing part and then do some past paper questions. Okay. Right. So now it's 7:43. We'll start at 8:05. Okay, so let's continue. Right, now we move on to our second part, uh, cloud computing. Right, so this is a different subtopic, but why this is together? Because we in cloud computing we heavily use virtualization. Okay, so basically cloud computing is delivering computer resources uh, as a service, okay, through the internet. Right? Servers, storage, databases, networking resources, software, even analytics, like your web traffic and so on. And these days, even something like ChatGPT and so on, those are cloud computing, right? So you asked question from ChatGPT. ChatGPT is those processing happens in clouds. You can see a lot of solutions depends on cloud computing. Either they have their own cloud computing resources, that is what Microsoft, Google, Amazon is doing, or you depends on others. So that is why cloud computing is a big business. Right? Google's business, Microsoft business, Amazon's business. And it's good for both, right? Of course, if you are a cloud provider, you get a good revenue. At the same time, if you are look other business, you want databases, web servers. So you can, rather than you set up your own servers, your own server rooms, data centers, so you use as much as possible these cloud services. So that it is more scalable, flexible, cost effective for you because these cloud providers take the heavy work, security, performance, maintenance, upgrading, all these things are done by these cloud providers. Right. So remember, virtualization and cloud computing are related. So virtualization help cloud computing. Cloud computing mostly deliver virtualized resources. So virtualization is the basis for cloud computing. Cloud computing utilize virtualization. So if you want, you can have your own virtualization, or you can use cloud computing directly as high level. Right. So these are the famous three cloud service models. So this is one of the most popular question in your exams. IaaS, PaaS, and SaaS. Infrastructure as a service, platform as a service, software as a service. Three possible or three cloud service models. So IaaS is the more basic or the low level cloud servicing where you get infrastructure, usually virtual machines or machines, most of the time virtual machines as a service. Service means you don't buy it, rather you pay for using that monthly basis, daily basis. So the new idea in business. So businesses, they don't like to buy things. They like to rent things. Rather than buying, you rent it. So the traditional approach is having rental is bad. You have your own thing then. For example, your parents will say, okay, you build your own house. Don't go for rents. Right? But businesses will say, don't buy buildings, don't build buildings, rent. They don't even buy vehicles, they rent vehicles. Right? Yes, high cost, but that gives you a lot of flexibility. Business is all about being flexible, not being rigid. There is a difference in thinking you need to do, right? So a lot of people will advise you to be rigid. And sometimes you may feel like that is the way to go, but that the way to go is being flexible, being agile. Then a lot of opportunities will be there. Okay. So IaaS is you provide infrastructure as a service. You don't buy a server, rather you rent a virtual server. So platform as a service means they provide platform for you to build applications, build, deploy, run, manage. It's application platform, not just the hard virtual machine. It's specific. So that means you have less work to do. So here virtual machine you need to configure and blah blah blah. And this is easier to deploy your application because this is a platform that gives you more flexibility. Okay. So the software as a service means you get the software as a service like Gmails, Salesforce is ERP system solution. And they configure it for you in their server. Or you can configure the software itself in their cloud environment. Like Office 365, Adobe Creative, those are all software as a service. So you pay for whatever you want. Don't pay unnecessary money. And always you get the latest software because it's under their control. Usually cheaper, flexible. You can add more features, less features. Okay. Lot of flexibility. So this is the modern thinking, flexibility. Right. So that is service models. So then deployment models. So what kind of environments you can deploy your server or app or whatever. Public cloud, private cloud, hybrid cloud, community clouds. So public cloud means like public transport. So anyone can use it. Of course, you need to pay for that, but it's available like your internet service providers, right? Anyone, if you're interested, can get the internet connection. Right? So that is called public cloud, like Amazon Web Services, Microsoft Azure. Those are public clouds. Even Google Drive, Microsoft OneDrive, YouTube, public clouds. Public cloud, because some of these are free also. But sometimes you need to pay additional things, right? If you need to increase the storage, you need to pay additional public cloud. Sometimes always you need to pay. But anyone can easily create account and get the service. That is what is my public. Private cloud means it's dedicated to organization. It's not that everyone get the access, even by paying. Hybrid cloud means mixture of both, mixture of public and private clouds. Community cloud means it's more like a sharing of resources among organizations and so on. So mostly those are community driven, right? Like charity work, so health, education, that kind of not-for-profit organizations, or they provide services for that kind of organizations. Public, private, hybrid, community. So what are the advantages of cloud computing? Number one is elasticity, flexibility, because you can add more resources, remove resources. When you really need a particular resource, you add it. You don't waste your money. That is called pay as you go. You pay for exactly what you are getting or exactly what you need. Okay, so you think about if you're a business minded person, right? Right. Remember we discussed about entrepreneurship, right? So this is a very important concept if you want to build businesses for the modern world, because a lot of people waste money, and the moment you make it flexible, there's a customers for you. There are customers for you because people don't want to waste. So then how do you compete with your competitor? You make your product or service more flexible. You only pay for what you get. Same thing, right? Scalability, on-demand access, high availability, because these cloud providers are specialized in those areas. Global accessibility, because these clouds are accessible from anywhere in the world, and sometimes they have multiple cloud sites, right? One cloud in USA, another cloud in India. So then you can ask, okay, I need my cloud environment in India. Maybe they have a cloud environment in Sri Lanka. Maybe it is Google Cloud, Amazon. So then, because why do you want to have cloud closer to you? If all your customers are in Sri Lanka, so if your cloud is, if they provide the cloud in Sri Lanka, so you better go for that. It's good for you. Faster response, high performance. It's good for them also. Less traffic, less internet traffic. Right. So the disadvantages of going for cloud computing is you lose bit of control because the clouds are under those organizations, right? You don't have the 100% control, limited control and visibility. Some security risks, especially very sensitive like banks, so they don't like to go for cloud computing. So they prefer to keep everything in their servers. Some legal and other issues are there because these clouds are in different countries and so on. And you need skilled system administrators, system engineers who can work with cloud environments, right? Sometimes you don't have much resources like that. So they should take, that is why system administrators these days, you not only configure your local machines, you must be able to connect to clouds, deploy your systems, okay, update, backup. So these are the basic concepts in cloud computing, like virtual private servers, of course, network, storage, identity and authorization, because these are clouds. Still, you need authentication and so on. Automation, automate backups, automate deployments. So there are scripting and tools. So there's a new concept called serverless functions. So that means you don't need long-lived infrastructure. So just a lightweight process serve and right. So then there's another request, you serve it. Rather than a server, those are lightweight processors. As I've already mentioned, when it comes to cloud services, there are regions, availability zones, especially by big cloud providers. We can ask for a cloud instance in Asia, cloud instance for Europe. So then your Europe clients will be connecting to server in cloud environment in Europe. where Asian users will connect to the Asian cloud. That's and there can be synchronization between clouds. Those are done by them. So these are some popular public cloud providers. So they have even asked this. I think last year they asked this. But who are the major public cloud providers? Right, the three major public cloud providers are AWS, Amazon, Google, DigitalOcean, and if you put it to fourth one, it is Microsoft has also clouds, big business. These are the three big guys, okay? Right, so remember, cloud computing gives you a lot of flexibility. So one flexibility is cost level flexibility. You only pay for what you get. You only pay for what you really need. That is the whole idea that drive people to use more and more cloud computing. Other than scalability, right, performance, cost control. So you pay as you go. You don't waste your money. Pay for data transfer, pay for storage, even pay for processing, pay for transactions, pay per transactions. So that means you only pay for what you really get. Right. So now we'll move on to few past paper, not few past paper questions, the past paper questions available in last 3 years on this topic. Just give me 1 minute. Right. So let's start with 2024. 2024 question 3. Right. A, B, C. That is full question, right? Last year full question on. So that means it's advantageous if you have full question because these are easy questions. Right. Question A. Write down the three most commonly used cloud service categories. Right. So service categories. So first of all, you must know exactly what they're asking. Okay. So what are those service categories? Software as a service, platform as a service, infrastructure as a service. You need to explain, right? So this down and then explain one by one. Explain how each one is different from the other. So that means basically you need to explain one by one. Take some examples, usages, and so on. And first explain what it really is. Okay. So anyway, we have discussed that, right? You can see long answers, right? Reference. That means you can see even the examiner's answers refer to the reference book. So that means examiner expect that you read the reference book and create a short notes and so on. Okay. So infrastructure as a service, platform as a service, software as a service. Okay. Right. So I'm not going to do those questions because pretty straightforward. Okay. Right. B part. Cloud providers maintain data centers around the world. Right. Remember regions so that customers can get the cloud in their region. So they use the regions and availability zones. So there is availability in Europe, availability in Asia, availability in uh, North America. That means they have a cloud instance physically located there. You can request, okay, I need my cloud instance in this zone, this region, as a standard terms to describe geographic related features. Describe each term and explain difference using examples. So that means you need to explain regions, availability zones. Okay, regions and availability zones. Right. So we have discussed that also. Okay. So these are again you can see basically examine a copy paste reference book. Okay. A region is a location in which cloud provider maintains data centers. So that is obvious, right? In most cases, regions are named after territory of the internet service, even though the data centers themselves are more concentrated, right? So they are just given example, but you don't need to go to that level, okay? USC is one, Virginia three. Anyway, I don't think that they expect this kind of details, right? But just you need to explain it with some examples. So some providers also have availability zones or simply zones, which are uh, collections of data centers within a region. Right? Zones within a region are peered through high band with low latency and blah blah. Okay. Right. So the last one, write three down, three cloud service providers. Write down three cloud service providers like Google, DigitalOcean, AWS. So those are the cloud service providers, right? Amazon, Google, DigitalOcean. Right. So that's it. So that is 2024. Now you can see that you need to go through the UC, not only the UCSC note, right? You need to go to the reference book because they only for this topic they only refer to about 10 pages. So if you can't go through that 10 pages, right? So then don't go for then don't expect A plus. A, maybe you can get C, but not A. So don't think that A is a cheap thing, right? A is expensive, right? There's a commitment expected, seriousness, right? So 2023, that year only one part, right? So that year just question 4C, question 4C, right? C part. Again, draw in front of each corresponding layer of which the cloud service provider is responsible for managing. So you just need to tick it, okay? So applications, obviously software as a service. You just need to put this tick. Database is application, right? Obviously application runtime is a, okay, application runtime. I don't know, can't we take it as a platform as well? Okay. That is little bit debatable. Okay. Uh, Operating system definitely platform, right? And they have taken, if they have taken a particular thing, they have taken the others also. I don't know why, right? So therefore, just use that convention. So for example, if they say platform, they all take software also. If they take infrastructure, then take, because I think the reason is once you have the infrastructure, you have all the access, right? So once you have the platform, you have the software also, right? So I think, so just use that convention if you get similar question, okay? So operating system is a platform, So therefore, they say it's software as well. Okay. A virtual network, again, platform and software. Virtualization platform. Uh, okay. So I don't know. They have taken it as infrastructure also. So little bit debatable answers. I don't know. So little bit debatable answers are there. Because there is a platform, but they have taken infrastructure as well. I thought it's platform as a service, right? When they even say platform. Right? So the examiner says virtualization platform, but maybe because this is virtualization platform. Okay. Then of course storage, physical networks, and blah blah blah. Maybe this is directly taken from your UC reference book. Maybe reference book has marked it like this. Okay, just double check. Right. So that here only one part. Uh, next, next we have the 2023. So there you have three parts, right? D, E, F. So it's 2022, right? Yeah. So this must be 2022. 4 D, E, F. Yeah. D, E, F. Uh, A, B, C part are from scripting. Scripting is the one that we are going to do next. Right? It's like programming topic, very easy topic. Right? 2022 DEF, D part. Right? In the context of virtualization, what is a hypervisor? So hypervisor is the software, sometimes software, hardware, firmware combination that facilitate virtualization or facilitate creating virtual machines or virtual containers. Okay. So likewise, you need to explain it. Then, of course, the type 1 versus type 2. Type 1 is a bare metal, type 2 is host. Right? So you need to explain, maybe you can draw a diagram for each. Okay. Hypervisor is a software layer that it mediate between virtual machines and the underlying hardware. Type 1 and type 2 separately explain. Okay. Right. E part. What is the three fundamental cloud service models? Okay, that is a repeated question. Software as a service, platform as a service, infrastructure as a service. And there you just need to mention, right? Because it doesn't ask you to uh, explain or discuss, right? Just what are, just you mention it, okay? And you don't need to explain. Right? F part, in the context of virtualization, what is a container? Remember, container is not a virtual OS, virtual machine with OS. Container is just application support. Just application support. Or you can just configure your service inside your container. You don't get a virtual machine, no, like a OS and everything. Uh, it's a common virtual machine. Different people get different containers. Application deployment environment, like Kubernetes. So you need to explain the difference between container and virtual machine. Virtual machine is a machine, though it's virtual, right? With OS, you can install software, you have access to the files. But here just container gives you a space, facilitate you to deploy, manage specific applications, so servers, services. Okay. So you need to explain that. Containerization is an OS level virtualization. It is different approach to isolate that does not use hypervisors. Instead, it relies on kernel features that isolate processors. You can see processors. applications from the rest of the system. Each process contains has a root file system and process namespace and so on. So then, of course, the second part is the container versus virtual machine. Right. So that's it. Okay. Right. That's it about. So you need to go through the uh, reference materials as well. Okay. Because you can see that the examiner just refer to the reference book. Right. So I will quickly go through your UCSC note also. Anyway, we have gone through. I just want to rush through it. Okay. Basically, our note had almost everything. So, what is cloud computing? Advantages, the three service models, right? Some fundamentals, ideas. You can see this straight from your UCSC note as well. They ask some three cloud providers. Advantages like cost control, then what is hypervisor, the four categories, full virtualization, para-virtualization, hardware assistance, and para-virtualized drivers, the type 1 versus type 2 other categorization. So some advantages, so advanced concepts in virtualization, live migration, virtual machine images, containerization. So virtualization with Linux, same KVM, kernel support for the virtualization from Linux. So then the containers like Docker, some frequently used commands. So I took that directly from here and copy pasted to our note. And they have given few more things, right? But I don't think they will ask about those things, right? Open source container engine related activities, right? But they say refer to the corresponding topic in for practical activities. Okay. But actually, what we are going to do this under semester 6. Okay, under QA. Uh, Under QA, we are going to deploy our certain things into, sorry, not QA, emerging technologies. We are going to look at Kubernetes again. Uh, that is under emerging topics, and okay, so we have something called, uh, yeah, microservices. Because microservices are more deployed in uh, this kind of application containers. You can see Docker, virtual machines versus Docker. Maybe you can refer to this semester 6 note also a little bit. Uh, you get access to both 5 and 6, right? Semester 5 and 6, okay? You can see the difference between virtual machine and app container is, so here you have the infrastructure, that is hardware, host OS, and then the guest OS. But here the Docker software is there because these are application containers. These are virtual machines, right? These are application containers just to deploy services in this case. You can't do anything else. But here you can install whatever you want, right? Because it's a OS, you can install databases, web servers. But here just specific tasks you can do. Okay. Right. So anyway, this is semester six. Okay. So I told you semester six is difficult. Semester five is easy. So therefore, you need to get your best results in semester five. Semester six subjects are much harder. Right. If you are interested in A's, this is semester five. You need to take your all your A's. Semester six subjects are way difficult. Okay. Right. So that's it for the today. Right. I don't want to do a separate topic. Remember, we need to do some past paper questions, few more past paper questions on information system security. So then only that subject will be 100% over. Maybe we can do those past paper questions in the next class, Friday class. Uh, and Friday class, possibly we want to do a maths topic as well. Uh, right. So now you can see pretty much our syllabus is getting over. Now today we finished this one. Uh, right. So then this one is just one day. But maths we need to do a lot of things, right? Maybe we can concentrate more on maths in the Friday class because now we are concentrating on these two topics, right? SNA maths because others are pretty much done. Okay. Right. We'll stop at this point, right? Thank you.